A very, very warm welcome to a new episode of Rethinking Resources. A big question this time. What if we could slow global warming by trapping greenhouse gases at their source and putting them in a safe place so they never get into our atmosphere at all? Well, it turns out we can. It's called carbon capture and storage, or CCS. Companies like OMV are looking to this process as an increasingly important part of the puzzle in accomplishing the energy transition. But for it to really play a significant role in getting to net zero by 2050, carbon capture and storage will have to be massively ramped up from where it is today. Critics say CCS is a false hope. Supporters say it will be impossible to get to net zero without it. To tell us more about carbon capture and storage, we are joined for this episode by Olivier Point, a geoscientist and senior project manager for CCS solutions at OMV. Olivier Point, welcome to Rethinking Resources.
Thank you. Hi.
Hi, great to have you here. So, big question to start off with. Olivier, how does carbon capture and storage actually work?
So I'd like to make a simplification to set the scene. If you want, CO2 is captured in the gas phase. It is then liquefied and transported into liquid phase. And then it is injected into a reservoir at depth in what we call supercritical phase or dense phase. And although it is a difficult thing to explain physically, you can picture the supercritical phase as a phase whereby the CO2 will have the viscosity of a gas and the density of a liquid. Now, what we do is we have a capture plant built next to the industry or the plant that emits CO2, and the CO2 is extracted, collected, and processed to be conveniently transported. That means brought down to a specific temperature and pressure regime to be liquefied. It is also dehydrated, and then it is transported by any means to the storage site. There it is injected into a geological formation, a reservoir, in the porous network of the reservoir, where it is supposed to be stored safely and permanently.
Okay, so now we have a rough picture of the process, but let's go back to the capture point. How exactly is CO2 captured? Are we talking about putting lids on smokestacks that are emitting CO2 or putting lids on other sources of emissions? Where exactly does the collection actually take place?
If you put a lid on a smokestack, you will suffocate.
Okay, so clarify it for people like me who don't understand how it works.
Capture is currently mostly happening at what we call the post-combustion stage. And this is, it has been taken place for decades now with the use of chemicals, and namely amines. Amines are a chemical compound based on a basic nitrogen atom. So basically, from the industrial site that emits the CO2, the flue gas coming out of it is processed, mixed up at low temperature with amine. And then amine captures the CO2. This is a chemical reaction. And that flux goes into a boiler where, to make it simple, where the amine will release the CO2 and the amine will be recycled to be reused. And the CO2, now purified, is aggregated, ready to be processed, as I said, liquefied and dehydrated.
Okay. So now you've got it captured. Can you transport CO2 over long distances, or does it need to be piped underground at or close to where it is captured? How far can you transport it?
CO2 is no different from other gases like hydrogen or hydrocarbons. And in a liquefied form, the industry has transported gases on very long distances in various forms, onshore and offshore. So this is no different. CO2, once liquefied, will be transported, is transported, thanks to absolutely any mean you can think of, onshore and offshore. So we're speaking about trucks, we're speaking about trains, we're speaking about barges, ships, vessels, pipelines, any mean that can convey it.
So, Olivier, at this point, I think it's necessary to address the voices of critics. They call it everything from, and I quote, a total scam to a false hope, saying it's too capital intensive, not economically viable, and that we are nowhere near where we need to be. So what do you say to the critics? How do you answer them?
Yeah, it's far from being a scam. This is very capital intensive. This is a fact. Like, by the way, all renewable energies. Offshore wind is extremely capital intensive. So the thing is, we need to understand that this is a necessity and not an option. CCS must happen and will happen. The second thing is that the investment environment is improving by the day, with governments putting in place some incentive policies that favor a innovation and technological progress. That there's a huge momentum right now in the CCS industry. I would also say that the business models have changed somewhat. We see that instead of emitters, especially big emitters, playing alone in their garden, we've seen lately industrial emitters gathering under a consortium to elaborate industrial hubs and, if you want, mutualize the means. So they are aggregating their CO2 emissions, or it will happen in these industrial hubs, and they will share the infrastructures to transport and aggregate the CO2 ready to be picked up. And that happens, of course, more favorably where there's a high concentration of industries along the coast. So we see these hubs quite well advanced in Antwerp, the port of Antwerp, the port of Ghent, or Rotterdam, or Dunkerque in France. All these hubs are progressing. All of this will make it happen.
Okay, but the mountain to climb is massive. Looking at the most current data I could find, in the year 2021, all of the ambitious CCS projects throughout the entire world, and there are many that are on the path right now, climbing this mountain, all of them together captured a total of just 40 million tons of CO2. Sounds like a pretty big number. So keep in mind 40 million tons, but to achieve net zero targets, we need to get to 1.7 billion tons in the next 8 years. So from 40 million to 1.7 billion, that's a 40 times increase. Is it even possible?
But again, we have to recognize it's a necessity. So I think all authorities, all governments, everyone, and all industries, industrial actors recognize it. And you know that it's not a necessity only for countries or nations. It's a necessity for regions. It's a necessity for cities. It's a necessity for companies. Everyone has now a net zero target for 2050. And to reach it, CCS is a necessity again. So we need to understand all efforts are being put, and I'll can detail it, but there are incentives to favor technological progress, with funds and help, financial help. And there's also, of course, taxes that help it. So there will be progress inevitably, and we are just in a nascent industry, but this will take off.
And there are certain countries that are going to be the first movers in this space. You happen to be based in Norway. Norway has long sought to be a leader in this technology. So what projects are you involved in Norway?
Yes, so what we do is we're developing a portfolio of projects. And these projects, the start of it is to secure acreage, namely license areas where we have identified a proper reservoir in a proper place to, I shall remind you, store safely and permanently and cost effectively CO2. So there's a whole process to license acreage, and that demands quite a lot of work because, of course, authorities will not grant you a license if you are not entitled or not seen as liable to it. Among the various projects we work on, one has been lately been awarded a license. This is license EXL005. Code name Poseidon. So we, along with our operator, Aker BP, we have now a license to work on. We're going to fulfill the planned work program, and hopefully we will develop that storage site and store in it the CO2 that we have identified.
Okay, so it seems like Norway's an exciting space and place for CCS. It has been a first mover. It's also had some setbacks in recent years, but going all the way back to the mid-2000s, Norway announced a very ambitious project, I believe at the Mongstad refinery. Jens Stoltenberg was the prime minister in the mid-2000s, and he held a press conference calling this project a world first, comparing it to the moon landing. Big promises. It didn't quite work out as hoped and planned. Tell us about that, why it failed, and if there's a fresh chance now.
Yes. I wouldn't call it a failure. And you know how it goes with official announcements, especially when at exciting times. And I don't want to comment on the way people convey messages. You know, I would compare that to SpaceX rocket. Do you see that as a failure, the fact that this rocket exploded, or do you, like Elon Musk, see it as a positive thing because it paves it towards success? Maybe we will actually go to Mars, and maybe it will take a longer time, and we'll see if in the future we'll speak about this explosion as a failure or as an event towards the achievement, the success. Only time will tell. Yeah. The TCM, Technology Center Mongstad, is the largest and most flexible technological center to test capture technology, and it has a great success. It is seen as a reference in the CCS world, if you want, for the actors. So this is where my analogy sits. You know, if you look back, maybe mid-2000s, when Jens Stoltenberg bragged a bit about this project, it may be seen as a failure, but currently it is not seen as a failure. This center is actually successful, and I bet in a couple of years from now we will just see it as a good success. It will have taken longer than expected.
Okay. And I appreciate the analogy because SpaceX says the goal was to get the rocket off the launch pad without blowing up the launch pad. So it passed that test. It got it got off the launch pad, and apparently all of the great experience and the tests that were passed will will be crucial in perfecting the technology in the years to come. So we're now in the year 2023. The world has changed immensely compared to the mid 2000s. The technology is better, but the problem is even more urgent. It's more acute. So what's the real potential of CCS, and how fast are we getting to realizing that potential?
Yeah, so to come back about net zero scenarios, the IEA net zero scenario targets or sets a target for CCS to represent 15% of the emission reduction, and that amounts to, if I remember well, 7.5 billion tons per year by 2050. So that gives you an order of magnitude of what we are aiming at, and I think to compare with, for example, storage capacity, because it has been studied. You were naming Norway, but obviously the whole North Sea in particular has been evaluated by the various countries: UK, Norway, Denmark, Netherlands. To give you just an order of magnitude of storage capacity, the UK, or the UK part of the North Sea, is evaluated to represent 78 billion tons of CO2, and Norway 85 billion tons of CO2 storage capacity.
Okay, which leads right into my next question, which is just how much CCS can help in the climate crisis. But the numbers that you just mentioned make it sound like it's really going to be a big piece in the puzzle.
Yeah, we have to consider that there are some front runners. The countries I just named: Denmark, Netherlands, UK, and Norway. But hopefully, we will unlock capacity in other countries across the world. Currently, it is banned in a number of, for example, European countries. But hopefully, when people realize this is only a benefit, the storage capacity will increase.
Okay, I'll come back to the countries that oppose it and why they don't want it being done in their on their geography and their specific borders. But let's get back to what critics are saying. They say that a big problem with CCS is that it still gives a green light to fossil fuel producers to continue operating as they are by using technology that sort of scrubs up, cleans up their polluting activities, and increasing the problem while trying to solve it at the same time. So this seems a bit like the snake trying to eat its own tail. That's the image that comes to mind. Is this the case?
Well, I would like to say that we need to take the problem in the right order. Among the 17 goals of the UN Sustainable Development, Goal 7 targets an affordable, reliable source of energy for all. And that requires the demand in energy is increasing. You can't help. So during the energy transition, we will need fossil fuel. This is a fact, recognized by IPCC, by UN, by IEA. So this is something that we cannot play with. Beyond that, I would say that CO2 emissions are not only due to fossil fuels. There are some industries that emit a lot of CO2, and it is quite known. These are called hard-to-abate industries, and I can name, for example, the cement industry, the steel industry. These emit CO2. So we can stop with fossil fuel. We won't have the energy we need to everyone, but there will still be emissions to abate, to offset. And CCS is there to offset these emissions.
Okay, let's come back to licensing and permission to be able to to use CCS technologies. You mentioned some countries do not allow it. Everybody seems very in favor of doing it in the North Sea, which is just somewhere far up north. Depositing it beneath the ocean seems like a plan that's fine for everybody. But why are countries opposed to doing it in Central Europe? Are there environmental and safety risks associated with CCS? Why don't they want it done in their countries?
Public acceptance is not always something tangible. It is very difficult to speak about this. There might be some ideology behind, and I can't really elaborate. In Norway, we know that the public acceptance for CCS is very high. It is very high for various reasons. It might be because it's one of the countries that benefited so well of the oil and gas revenue. But it is also because we store offshore. So, of course, it's distant. Now, to come back to your question about safety, I would like to come back to the basics. CO2 is an inert gas. It is absolutely harmless to living organisms. It becomes an issue only if the concentration of CO2 is such that it replaces air, depriving living organisms and human beings from oxygen. So because it's denser than air, it will replace it and where we live and will deprive human beings from oxygen. But that would happen only at a punctual location and in case of an accident. So, namely, if there were safety issues around CO2 transportation or CO2 presence, it would be in the infrastructures that either collect or transport or inject that CO2. But that is something that we are used to doing in other industries or with other gases like hydrocarbons, like hydrogen, and there's no more risk than with these. And I would even say, because it's an inert gas, there's less risk. In terms of storage, where we inject CO2, there's definitely a lot less risk, because we carefully select sites where we will be injecting that at depth, as I said, and this is a minimum of 800 meters. It can be 2,000 meters below surface, into rocks that are sealed. We carefully select the sites so that the containment cannot be breached. And we have to do it seriously because the authorities will anyway check it. And as I said earlier, we also need to monitor it over a very long period. During the whole injection period, that can last between 20 and 30 years, and beyond. 20 years during what we call the financial security, and then 30 years after. So it's more than a human being lifespan. In these formations, geological formations, if there was unexpectedly a leakage to happen, it would be diffuse streams that would go through, as I said, a minimum of 1,000 meters of rocks. So what would come out at the surface would be diffuse streams of CO2.
Which would be self-defeating because you're then releasing the CO2 back into the atmosphere, but not dangerous. We're not talking about pumping poison into the earth. It's just that...
Exactly. I wanted to say that because if a leakage was to happen, which is extremely unlikely in storage site, it is harmless. Now, I'm not saying it will happen. We are doing everything in our power to make sure that it won't happen. Again, our goal is to store it safely, permanently, and cost-effectively.
Okay, so let's talk about then momentum, a positive tipping point that means this is actually going to happen with the right level of momentum that is necessary for us to get to net zero by 2050. As mentioned, we're a few steps down the road, but we have an immense mountain to climb. So I think it's relevant and necessary to talk about the business model for CCS. Another issue the skeptics point to is that if you capture CO2 and bury it, it's gone, which is good in an environmental sense, but in reality, it means it's no longer a source of revenue. This means for-profit companies might not have a great interest in it because it's just a cost position for them. So is there a model where there are clear environmental and financial incentives? So is there a clear win-win that is actually going to encourage companies to do this?
I'd like to be a bit provocative here. What do you do with your garbage at home?
Here in Austria, we separate the trash, and we've learned over the past few years to do the right thing, and once you learn how to do it, the system seems to work.
Yeah, but you pay for it to be
yes.
removed from you,
yes,
to be handled, processed, disposed of. This is basically what we propose to do with the CO2. If you had CO2, OMV would come to you and say, well, if you pay us enough, and of course it has to be good enough for you as well, then we remove your CO2 and we promise we will store it safely and permanently. This is true. CO2 must be seen in CCS as a waste, and it is handled as a waste, or at least it's not a commodity. But like every other waste, you pay for it to be disposed of.
Okay, let's talk about a sister concept that has caught some interest, CCUS. CCUS stands for Carbon Capture Utilization and Storage. This involves putting CO2 back into the value chain as well as storing it. Tell us about this.
Yes, so utilization has been known, of CO2 has been known for decades, and this is quite common. There are basically two major areas. The biggest one is the fertilizer industry, using CO2 to make fertilizers. So the second biggest utilization of CO2 that has been known for decades and mostly used in the US is the use of CO2 to enhance oil recovery. And basically, to make it simple, you mix it up with soap to use that foam at depth in the reservoir to liberate more easily the hydrocarbon molecules. But if you take these two parts, that's by far more than 95% of utilization. CO2 is seen as potentially being used in other areas, in products and services like materials for building, or use of CO2 for to promote plant growth, for example. But these sectors are seen as having a limited growth potential, at least in the short time. So it is not representing, it's the same order of magnitude as the CO2 used for food and beverage. And to give you an order of magnitude, we use yearly, worldwide, 10 million tons of CO2 for food and beverage.
So not a lot.
It's not a lot. It's not a lot. So the utilization might grow. Again, we don't know. We need to be very careful, and mankind is able of a lot of technological progress. But it is not seen as an alternative to CCS. It is seen merely as a help or a combination.
Okay, so you've painted a pretty clear picture of the technology, how the technology works, and a big light bulb went on for me when you were able to clarify pretty clearly that it's going to be a pay-as-we-go thing. It's, you know, if you compare it to collecting the trash, then it seems reasonable and feasible, and a goal we can accomplish. Recent years have brought some successes, some positive momentum. We've also seen some false starts, some failures. But right now, spell out your vision for the future and your real expectation. Will CCS get us to net zero by 2050?
As an individual, I have to say yes, without any doubt. We are bound to succeed. And again, this is seen as a necessity, not an option, and we work hard at it. What we see, the momentum we see in the industry itself, and I am within it, is the momentum is crazy. This is a race we are engaged into. Of course, projects will take many years. We're speaking about something like 5, 6, 7 years. It's shorter than conventional projects, but it's quite fast. And what we see is that to speak only about Norway and the Norwegian continental shelf, where, as I said, we evaluate the storage capacity of 85 billion tons of CO2. Most of the interesting acreage will be secured in the coming years, in the 2-3 years to come. So I can only say yes. I think we'll be there.
The vision is clear. Olivier Point, thank you so much for sharing your thoughts, sharing your ideas, and of course your insights with us on Rethinking Resources. To everybody listening to the episode or watching on OMV's YouTube channel, if you have feedback for us, if you have questions for us, please send a message to podcast@omv.com. We would love to hear from you or get that message. For more background information on the topics we discussed in this episode and our guest, check out our show notes where you will find links to lots of valuable information. Thanks again for sharing your time with us in the audience, and we hope you will join us again for the next episode of Rethinking Resources.